In this video, we're going to introduce the concepts of multiplication of two vectors. Any vectors can be multiplied in two ways. One is called dot product, or scalar product. The other is cross product or vector product. By name, we can see that when two products are multiplied using a dot product, the answer is not a vector but a scalar quantity, and that's why it's called scalar product. However, when we do a cross product between two vectors, the answer is again a vector quantity, and that's why it's called a vector product. In this video, we will deep dive more into dot product, and in subsequent videos, we will talk more about cross products. Dot product. Let's start by defining what the dot product is. If you have a vector A, and let's talk about three-dimensional space given by A1 I cap plus A2 j cap plus A3 k cap, and a vector B with B1 I cap plus B2 j cap plus B3 k cap, then dot product between A and B is given by A1 B1 plus A2 B2 plus A3 B3. So this is what we call the definition of a dot product, right? So note few things. Note notation. So dot product is given by A point B vector, right? And the other quantity, this is basically a multiplication of scalar numbers. So A1 B1 A2 B2 A3 B3. There is no concept of direction here, so there is no I, j and k cap, and so this is a scalar quantity, and hence it's a scalar product, right? So this is one of the simplest form of doing product between two vectors. Let's talk about an alternate definition of dot product, right? So it says that A dot B is given by magnitude of A vector into magnitude of B vector into cos theta, where this is A vector and this is B vector, and theta is angle between the two vectors, right? So this is an alternate definition of dot product, right? What does that mean geometrically? So geometrically, it means that if you have a B vector and A vector, theta, then if you project a vector A on B, then these two are within the same direction, and when you multiply this, right, this is a scalar quantity in the direction B multiplied by another scalar quantity in this B will give you a formula A cos theta A vector B vector cos theta, that is A vector dot B vector is magnitude of B into projection of A vector on B vector. Equivalently, we can say A vector or magnitude of A vector into projection of B vector on A vector, right? We could have, this is A cos theta. We could have said projected, instead of projecting A, we could have projected B on A. We'll then have B cos theta, right? Okay, so we have seen two different definitions of a dot product. However, what is dot product good for? As we'll go more deeper into vectors, and as you will also go more when you are solving physics questions using a vector, you would often need to find the length of the vector or potentially an angle between the vector, right? So if you know a vector, then it becomes very easy to find using this formula what is an angle between the vector. Similarly, if you know a particular length of a vector, it becomes easier to find another length of a vector if you know the angle between them using a dot product, right? So let's see some important operations. So if you have a vector and you do a dot product of that vector, then what does that mean? So that will be A1 into A1 plus A2 into A2 plus A3 into A3, which is equals to A1 square plus A2 square plus A3 square, which is mod of A, or the magnitude of A vector whole square. Using another formula, we can also prove that, like A dot A is equals to magnitude of A into cos of the angle between them is 0 degree, which is equivalent to 1, and therefore this is A square, right? So whether you use a formula 1, use a formula 2, you would come to an answer that A dot A is magnitude of a vector whole square. Another important concept, if you have A dot B which is equals to B dot A, right? To prove that, so A dot B is equivalent to A1 B1 plus A2 B2 plus A3 B3, which is equivalent to B1 A1 plus B2 A2 plus B3 A3, which is equals to B dot A. Right? It's also true because this is a scalar quantity and does not have a direction. Hence, A dot B is equals to B dot A. Those are the two important operations that you should remember, which will be very helpful in solving various problems using vectors dot product. Okay, next, let's talk about some application of dot product. So if you have a triangle ABC with angle theta, and this is A, B, and C as the length, then there's a cosine law which says that C square equals to A square plus B square minus 2AB cos theta. Right? Can you prove this using dot product? You'll see the solution in the next video.